Hi students, this is Dr. Radha, your chemistry lecturer. I am here to welcome you for today's session in the structure of atom chapter. Today I am going to discuss about hydrogen spectrum. Students, before going to the actual meaning of hydrogen spectrum, first let me take up what is the meaning of spectrum. What do you mean by spectrum? So something we are calling it a spectrum. So what is that meaning of spectrum? Let us see now. Students, for example, you assume that we have got a prism. This is a prism, like that you assume. So on this prism, when I make white light to incident, you know very well, white light is composing of 7 colors. So this is a white light. So what is going to happen? In the white light, there are different colors are there. I mean 7 colors are there. The color which has got shortest wavelength will bend to the larger extent, and the color which has got largest wavelength will bend to the least extent. You know that one. So here, when a white light is passed through the prism, actually here splitting of white light takes place, you know very well. So violet light. So here the violet light bends to the larger extent, you know very well, because its wavelength is, here the wavelength region is 7 into 10 power 14, 7.5 into 10 power 14, you know that. So like this, what is going to happen? Splitting of light takes place. Finally, we are going to obtain what? 7 different colors, right? With Goyard, you know that one, right? So here, due to the splitting of light, so what is going to happen? Here, 7 different colors we will get from the prism. So what exactly? With Goyard, like that we can write. So like this, 7 different colors we will get, right? Now these radiations, these light radiations which are having different wavelengths exhibits a different color. When these colored light radiation is allowed to fall on the photographic plate. It is a photographic film, so which is a black plate actually. So on this, when you make these colored radiations to fall on this plate, so what is going to happen here? Formation of collection of different radiations takes place. Okay, so that collection of different radiations having different wavelength. So that collection of different radiations of different wavelength on the photographic film, that we call it as what we call spectrum. See here, now this is a prism. On this prism, when white light is made to fall, so what is going to happen here? Splitting of white light takes place like this. So this is violet, indigo, blue, green, yellow, orange, red. We call it as with Goyard. So red light has got largest wavelength, so it bends to the least extent. Violet has got least wavelength, so it bends to the larger extent. So here the splitted colored light radiations, when it is made to fall on a photographic plate. So here what is going to happen? See, this is a photographic plate. Now the light radiation that is passed through the prism splitted into 7 colors, and on the photographic plate what is going to happen here? Collection of these light radiations of different colors having different wavelength on the photographic plate takes place. So this collection of radiations of different wavelengths on a photographic plate, we call it as a spectrum. I hope you understood, students. Now spectrum means it is a collection of or a number of, number of light radiations, series of light radiations, so which are having different wavelengths, which are collected on a photographic plate, that we call it as what we call spectrum. So this is the actual definition for spectrum. Now here, when a ray of light is passed through a media on any substance, so what is going to happen? Part of the light get absorbed, part of the light get emitted, part of the light get transmitted. You know that one, right? But here the two important phenomena, that is absorption and emission. When it comes to the light and media, what are the two important phenomena we will come across? Light may get absorbed, or what exactly? Emission of light takes place. So here there are two types of spectrum you will come across. Now types of spectrum. See, now I am going to take up types of spectrum. One is known as absorption spectrum and second one is known as emission spectrum. Students, here now types of spectrum. So there are two types of spectrum. One is known as absorption spectrum. And second one is known as emission spectrum. So now, what do you mean by absorption spectrum? Now, let me take up this absorption spectrum. See, for that, I am going to take up some examples. With example, I am going to explain. Students, please consider this as a container. Okay, this is a container. Now, in this container, I am taking a liquid. So, this is a solution like that, you assume. So, this is solution. Now, when a white light is introduced into this solution, this is a white light. Now, I am passing white light through this solution. So, what is going to happen? The atoms which are present in the solution, which absorb part of the light. What do you mean by that? White light composing of what? 7 colors like that I told. So, among those 7 colors, the atoms which are present in the solution may absorb 2 colored light radiation. See, for example, this light radiation is composing of 7 colors like that I told. When it is passed through this solution may absorb blue and green light radiation like that you assume. Now, the white light is introduced. Now, what happened now? This solution absorbed blue and green light radiation. Then, the rest of the colored light radiation, what is going to happen? It will pass through this solution. Okay. So, next, the different colors. See now, which is excluding what? Blue and green color. Now, this light radiation, when it is allowed to fall on the prism. So, what is going to happen here? Of course, it will pass through the prism, and here again, these colored light radiations, I mean this white light radiation, now it is excluding blue and green light radiation. When it is passed through this prism, what is going to happen here? Splitting of light takes place, of course, but here it is not having blue and green, right? So when this light radiation is made to fall on a photographic plate, so what is going to happen? Of course, this photographic plate will show some spectrum. See, for example, here it is showing yellow colored, and then it will have violet color, right? And it is having blue color. I'm sorry, it is not having blue color now because blue and green light has been absorbed, right? So here, this is a black background actually. Now red light radiation. So like this, what will happen? All other different colors will be there, but excluding what? Blue and green light. So actually at this region, for example, you assume it is supposed to be blue and green light, okay, on this photographic plate, but which is already absorbed by that solution. So the wavelength which is corresponding to that blue and green. So here what will happen here? So here there is a formation of black spots takes place on the photographic plate. where blue and green lights were supposed to be recorded, but it is already been absorbed. Thereby, in that place, what will happen? Some black spots are going to form on this what? Colored background of the photographic plate. So, these black spots which are present on the photographic plate, so actually this corresponds to the what? The wavelength of the light radiation which is being absorbed by the solution. Now the black spots which are formed on the photographic plate corresponds to the light radiation absorbed by the solution is known as what we call it as absorption spectrum. Now what do you mean by absorption spectrum? Means it is the spectrum where the collection of light radiation of different wavelengths takes place on the photographic plate, where these light radiations, okay, so here the light radiations are placed between what exactly? The blank space or dark space. So the dark space represents what? The light radiation which is absorbed by the solution. So that we call it as what we call absorption spectrum. So here absorption spectrum is recorded on the colored background photographic plate on which the dark spots indicates what? The amount of light absorbed. I mean the wavelength of the light absorbed by the solution or media. Okay. So this we call it as what? Absorption spectrum. I hope you understood here. So due to the amount of light or the light radiation of wavelength absorbed. So here that will be indicated by what exactly? The magnitude of what? Dark spots which are present on the photographic plate. Now, the second type of spectra, what I told, emission spectra. Now, what do you mean by emission spectra? So now I am going to take up this emission spectra. Students, again I am going to consider a container. So now in this I am taking what? A solution. So now when your white light is allowed to pass through this solution, okay, so this is a white light. So what is going to happen here? I told blue and green, for example, it may get absorbed by this solution, like that you assume. Now here, this light radiation is absorbed by what? Electrons. So when the light radiation is absorbed by the electrons, actually electrons are present in the ground state, you know very well. The electrons of atom present in the ground state energy level. Once the electron absorbs the energy, what is going to happen here? That electron goes to the higher energy state, that we call it as excited state. Okay, after taking energy, that electron will go to what? Higher energy. So in the higher energy actually, so electrons are unstable because it will reside there only for a period of 10 power minus 8 seconds. Okay, in the higher energy state, electrons are most unstable and it can reside only for a period of how much? 10 power minus 8 seconds. Thereby what is going to happen here? Electrons tend to revert back to the ground state energy level. Okay, or lowest energy level. While reverting back from excited state or higher energy level to the lower energy level, here how much amount of light energy that is absorbed. So that will be what? Emitted by these electrons. Is it clear now? So that emitted light radiation, when it is recorded on the photographic plate which is having dark surface or dark background, what is going to happen here? The formation of bright lines takes place. See here like this. Formation of bright lines takes place. So these lines which are corresponding to the wavelength of light radiation which is absorbed. Okay. So here these wavelengths that are formed on the what? Photographic plate, that is due to the emission of what? Light radiation.